Hello and welcome to the latest Python tutorial for the Blender game engine. In today's video we're not going to focus on Python as a language but as an integral component into the game engine. So without any messing around, let's get this thing started as quickly as we can. So first things first, you need to create a new text file. Now in previous lessons we've simply just renamed it something logical, but in this case we're going to be using a special form of controller. So we need to name our Python script something logical. So firstly, let's think of a name. Well, this is going to be a test file, so we'll call it test file underscore file .py, and you must put a .py extension for this form of tutorial. Now we're going to add an import statement. We're going to import the BGE, which is an acronym for the Blender game engine, and that should be all for now. Now what we're going to do is we're going to define a module. So if I make this text bigger so we can all see, we're going to define a module, and we'll call this module is basically a function. Modules are able to access, module mode accesses a function, but it can access a function from a module, hence its name. So we're going to create a function, and we're going to call it, let's say, test. Very ingenious name here. And we're going to add parentheses for the arguments, and we are going to accept an argument in this function. We don't have to use an argument in module mode, but it makes things simpler because it fills in a parameter for us. So we're going to type cont. Now if you've seen Blender scripting already, you'll be aware that cont is the most commonly used acronym for the controller. But if you aren't, then there you go. So in Blender game engine, everything is object orientated, as in most Python applications, and what this means is that we can access attributes and interact with other objects using attributes and methods, and it's a very self-contained, self-interacting system. So we need to know a bit about the game engine in case you aren't aware. Firstly, we have the SCA concept, or the game loop, which forms a part of the game loop, and this is the game logic. And SCA is a sort of an acronym again, or for sensors, controllers, and actuators. This is a form of an event loop, which means that an event triggers a response. But in the SCA loop, an event is triggered from a sensor. It goes through a controller, which then decides whether or not to trigger a response through an actuator. So a typical example would be adding an always sensor connected to an AND sensor, and then add an AND controller, and add a property actuator, and the property actuator you can modify any form of property we give. We can debug this property. If you aren't aware, I've got a different UI to you guys here. I've got these two buttons which allow me to order properties, which is in the game engine support forum, I think, and also in the Python Blender scripts of Blender artists. So we could give it a new value of test, because test is a very commonly used word. And you'll see that if we debug this in the game engine by going to Blender game, show debug properties, you'll see, if I enabled it correctly, that, oh, sorry, my nose is, we have to give this a string attribute, so we'll have this as default. And when we start the game engine, that we set to, oh, that's interesting. Oh, of course. You have to add speech marks around it. And you'll see it says test, which is very good. Now, this is very simple. An always sensor without true level triggering, which means that it runs continually true. But because it doesn't have true pulse enabled, it doesn't send the disabled pulse or the inactive pulse. So it doesn't do anything to the sensor. The controller, sorry, does not get updated. So in the game engine we have this concept, and Python doesn't particularly fit as nicely into this as it should do, because Python can be used as a controller, but it can also be used as an actuator. It can interact with the game engine directly without using any of these actuators, so it doesn't quite fit. It should almost be in this sort of entire section here rather than just in the controller loop, but that's not the end of the world. So let's set up our test environment and add a Python controller with an always true pulse triggering, or let's disable true pulse for now. And you'll see I've set this to module rather than script. Why have I done this? Well, it's two reasons. Firstly, if you use it correctly, it's more efficient than using script processing, and it also means you don't have to type in controller every time, which gets very tedious. So we need to type in here test underscore file, which is the name of our Python script, then a full stop, or a period if you're American, and test, with no parentheses, and that will run the module, the function test inside the module test file, and it will pass a controller argument if you specify, otherwise nothing at all. So now what do you do? Well, controller is the access to this controller brick in Python. And if we want to get the object running this code, we can actually access the owner of the controller. So we type own equals cont.owner. And this now that's a game object that is accessing this game object here. Now, if you're ever worrying about or wanting to know what you can do with everything in the Blender game engine, you need to know the Blender game engine API. So if you access that, I'm going to open a new window if I can. Windows R. And I'm going to close the other tabs. And now we're going to go to, I've already got this in my bookmarks, it's blender.org/documentation. And if you type in blender_python_API_2_63_13, or copy this out, you'll see my most recent, well, in this video, the most recent Python API. Now you can see if you scroll down, you'll see game engine modules, and this is what we're interested in. So let's just describe this firstly a little bit. You've already been introduced to game objects, and objects rather, in Python. All classes and modules and everything is derived from an object. And this means that everything is derived from a type of Python object, or a type. Now everything derives from type, which is a Python function. You can use type to print the type of an object by using the type function, but you can also create Python objects with the type function. So this is why we have something called game types. This is where this is the objects which everything else in the game engine is derived from. So if we look at BGE.types, you'll see this BGE.types.pyObject+. Now we can ignore this. It's essentially, this is what, if you see errors mentioning this, it means that a Python game object has an error with it. And you can test if this object has been deleted in the game engine. It can be any kind of data that's been deleted by testing for invalid. And because this runs outside of the garbage collection loop, you'll always have an invalid attribute. So don't worry about anything if you don't understand that. That's fine. Now let's look very quickly into the track control find, and we're going to look for game object. Game object. So let's go down until I find it. And actually, if you click on the link that was just above here, you can actually click on it and find it. Where are you? So go down, go up somewhere, here we go. So if I click on that, you'll see now I've got the class game bge.types.kx_game_object. Now kx_ stands for Kejtsi, or Kejtsi, I can't remember how you pronounce it, it's Kejtsi, and that's the code name for the Blender game engine functions. Now, if we look down, we can see all these attributes, and these are everything that the game object has. So if we printed all of the attributes of a game object, you see all of these attributes. And that's just a bit of background reading. So when you need to find anything in the game engine API, you'll be looking in the documentation in the game module somewhere. Typically in bge.types and sometimes in bge.logic. Sorry, I'm rushing through this one, but just bear with me. So, what we're going to do? Well, firstly, properties. Everyone wants to know about properties. And sensors. Typically, you will be using sensors in the game engine. Now, sensors trigger controllers, but they can trigger controllers in different forms. The way in which this works is as follows. When a sensor is triggered, let's say a keyboard sensor, it will send a pulse to the controller. And it sends a deactivation pulse when it's deactivated. So in this case, if I had W key, and I just remove the sensor to show you an example. If I make it print triggered in the console, we now need to show the console. And if you go to help toggle system console, I've added a keyboard shortcut by right-clicking it and changing the shortcut, or adding a shortcut. Now, if you start the game engine and do things correctly, which I probably haven't, yes I have. Now, when we press W, you'll see it triggers twice. And to show you this better, I'm going to hold W for 3 seconds. So 1, 2, 3, and release, and it triggers it again. This means that it sends the activation pulse, which is when the W key is first pressed, when you press the key. And then as soon as I release the key, it sends the deactivation pulse, which means that it is now negative. Now, the way in which this works is that things like actuators, with action actuators and all sorts, when the negative pulse is received, it will try and stop the animation in the form that you specify, either loop end, or so on. So this means that this is actually triggered twice. So we all expect it to just be triggered once when you press a key, but that's not the case. So we actually need to check, if we want to only do things once when the keyboard is pressed down, we want to check if that's the case. So firstly we need to access the sensor, because we need to know whether it's been pressed or not. So we can type keyboard equals conf.sensors and then the name of the sensor. So I'm going to type keyboard, because you see it down there. Now, a little side note, you can actually access keyboards as a list using 0, 1, 2, 3 as names, or you can iterate through them and find the type. I'm going to show this very quickly now, so skip over this if you don't want to go into advanced Python. But a lot of people do this and they hard code their names, and yeah, sometimes you'll want to hardcode sensor names if you're testing, but often you just want to know that there is a keyboard sensor attached, and you're only ever going to have one, perhaps. In that instance, what you can do is check for the types. So if we go into BGE.types on the documentation and look for keyboard sensor, you'll see we have a type. Now if we copy the name of the keyboard sensor here, BGE.types, all the way up to the brackets before the parentheses, we can now type keyboard underscore type equals that. And it will import it from the BGE module. Now we can say keyboard, if I go and comment this out, keyboard equals S for S, oh dear, I'm getting a mechanical keyboard soon, I'll sort this out. S for S in keyboard, dear me, const.sensors. So basically, it sets the variable of S to each item in the controller.sensors list, and it creates a list with that value. So it iterates through and sets this variable, as we do with for statements, and then adds it as this into a list. So if we did that and we printed keyboard, and add another sensor just for an example, let's say an actuator sensor, which we won't trigger, and if you now press P and press W to trigger it, we see it has two sensors, and that's a list. It's not a Pythonic list, it's actually a specialist class, but it works basically as a Python list / dictionary. And now we can add an if statement. If is instance S, keyboard type, which means that it will check if that sensor class is an instance of the keyboard class, which it will be if it's a keyboard sensor. Now, if we do this now, you'll see that it prints only one object. I think. Let's just have a look and see. Oh yes, I didn't print it. So print keyboard, and we run this and press W, and you see it only has one item in the list. And now we can extract this item from the list using just the zero index, because it's the first item in that list. Now, if you don't have a keyboard sensor, and we delete as follows, you'll see we have a problem. If I make this in always, you'll see this. He says, list index out of range because it can't find any keyboard sensors. So that's all that really matters. So I can delete the keyboard sensor for now. So let's change this back to a keyboard sensor, make it a space, and call it keyboard. Now, if you're just joining us after that previous break, all I've done is add an automatic detection for a keyboard sensor. And you can do this for all other types of sensors in the game engine if you use the control find on the API documentation. So make this full screen, and now let's carry on. We want to know if the sensor has been pressed, because otherwise it triggers twice, as we've already seen. If I demonstrate once more by removing this window and pressing W, space rather, and adding back in some code that I removed. And you'll see no errors happen, and it's all fine. So you've already seen const.owner is the owner object we've accessed as an attribute of the controller. And don't worry about this if you haven't seen it, it just gets the keyboard sensor. So now we need to check if the keyboard sensor is being pushed. Now how do you do that? Well, keyboard sensors have an attribute of positive. You'll see it as is positive in 2.49 Blender or below, but we don't use that anymore, it won't work. So we can add an if statement, if keyboard.positive, which checks if it's been pushed down as a positive pulse. Print push down. Now if we press that and press space, you see it doesn't say it twice, it only says it once. And to show you how this works, if I add another if statement, elif keyboard.positive, and we just change that to not, print push key up rather, and you'll see it goes push down as I hold it, and then key up, push down, key up, push down, key up, and that's how we check. Now most of the time you won't care if it's not positive, so we don't do anything, but that's how we check if the keyboard is positive. Now the brilliance of module mode is that if we don't really want to use the sensor if it's not being positive most of the time, so we can add a return statement, which basically means that it won't do anything. So if I print only if key down, in a print statement, press space, it says push down. Oh no, let me change this. If not keyboard.positive, we return. So now it does the same thing. If I hold space, it says only if key down, and if you're not holding down, it returns and escapes out of the function. So this is why the model mode is very useful. Now, what else? We've checked if sensor is positive, so if you're pressing the sensor, but what else can we do? Well, we can also modify an object. Now, objects, typically, you'll want to modify properties, which is what I was talking about earlier. So I have a property called prop, and it's set with a string of default value, and it's a debug property. What if we want to change this? Well, let's make it add a full stop to the end of the string each tick. Now, the game engine works in ticks, if you're not aware. 60 ticks per second is the typical. The tick rate is the same as the frame rate. It's tied to the frame rate. And you can set the frequency of pulsing of each sensor, but typically it's set to 0, which means if we enable true pulse triggering and set this to an always, and delete this code here. In fact, no, let's leave this code as a keyboard, but set to true pulse. Which means when you hold down the spacebar, it will continue to send positive pulses as well as negatives. Or does it? Yeah, it does. It just sends positive pulses. It just sends positive pulses. Now, only if key down, let's have it so that it adds a full stop to the end of the property every frame. So we need to get the property. So the property is stored on a dictionary on the game object, and that dictionary is also pointed to the actual game object itself. Now, if you don't get what that means, don't worry. But basically, even though the properties are stored in a special dictionary as an attribute of the game object class, you can access them straight from the game object by using the dictionary style access. So, if we were to print own, and then using the square brackets with speech marks, prop, to access the string, name, we'll see, if we press space, it says default, which is brilliant. And if we delete this debug statement, you'll see it says default. Now, and you'll see in top left as well, in the top of my screen, it says default up here. We've accessed the property here, and that's the property name, and it gives you the property value. We can now modify this to plus equals, which is an in-place operator which adds a value to this property, a full stop, which will add a full stop each tick to the property, because you can modify properties as well. Now, if we look at the top left, nothing. It still says default in the debug properties. If I hold space, you'll see it adds. Do it again, you'll see it adds. And that's very useful indeed. And that's how you can access properties. Now, what else can we do? Well, we can also modify object attributes, and you'll see here we've got something like game object. If I click on that, and we go next. Right, so you can access all these attributes, and we can access orientation, position, all that, but we don't want to use, don't use position and don't use orientation, and I'll tell you why in a minute. Because they aren't the same when you access and read them. When you access them, by reading, they're world orientation, but when you set them, they're local. So they're a bit odd. We don't really like to use them. Instead, we have different variables for each type. So we can access the world position or the world orientation. This is typically all you need to know about until you get into parenting. So let's move this game object. World position is somewhere up here. Find world position, and it returns a list, or a vector rather, of its world position, and you can set it from any iterable type. So position equals own.world position. Now the brilliance of this is it returns a reference to this position. So this is now pointing to the game object position, which means if we modify this variable, it will actually modify the game object's world position. So position.z plus equals 0.1, and this is because as a vector we can access the z-core position of this vector. Now if I scroll out and press play space, you'll see it goes up, and that moves your object. And that is how you use world position. And you can do the same. You can actually set the world position equals position 0, comma, position 1, and then position 2 plus 0.1, and it does exactly the same thing. Oh no, maybe it doesn't actually. Let's have a look. Perhaps I need to add parentheses. That is interesting indeed. No, of course. I'm being very stupid. I'm actually just replacing this. So if own.world position, you have to actually modify the game object. Well, does that. So it works in the same way. sorry about that. And that is all the introduction to the sensors and modifying the object by Python. But we often want to modify the object using the built-in actuators, which is a very sensible thing to do. So let's add a game, quick game. We can access this actuator in the same way we actually accessed our sensor. So let's remove this position code, or this position scripting, and then we simply type end game equals cont dot actuators game, and we could do the same as earlier and detect it automatically, but we don't need to for now. Now this gives us the actuator. Now that just gives us a reference, and if we press space it doesn't actually do anything. But if we make it activate this sensor, no sorry, I'm very tired. If we activate this actuator, as we do with sensors, typically with the true pulse triggering, we can perform its function, which in this case is quick game. So if we type cont.activate, which is the controller.activate end game, you'll see as soon as I hit space, game stops. And that is the introductory video. I'm going to run another video next time, but this is just the basics for how to use the internal game API. And until next time, good luck and keep practicing.